Hello and welcome. I am Anuja, a recent graduate from San Francisco State University. I would like to present my paper on Internet of Things using Node-RED and Alexa. Internet of Things is revolutionizing our daily lives and the way we interact with each other. This paper enhances on how far IoT can connect devices on various platforms. This will effortlessly help humans in various fields like home automation, networking, data monitoring, and others. The proposed system connects and controls most of the IoT devices using voice. It also introduces a new and effortless connection of IoT devices using Node-RED. IoT makes virtually everything capable of being monitored, analyzed, and acted upon by an array of computers with little or no human intervention. Some of the examples of Internet of Things are the wearable tech, home automation, and smart city. Human machine interaction plays a vital role in diverse fields such as education, industry, and cultural development. Until the late 1970s, the only humans who interacted with computers were information technology professionals and dedicated hobbyists. This changed with the emergence of personal computing in later 1990s. This is the very first generation of this kind of machines, which is familiar for most of the people. Through monitors, people can read the outputs from the computer, and the input is captured by monitors. A computer mouse allows a smooth control of graphical user interface, and that is also the reason why this is accepted and loved by the population. It is also when computers really took off as a popular technology and came into our daily life. Touch screens really empower people to use our fingers to directly communicate with computers in very native way. By doing this, the interaction with computers has been significantly simplified. It is an emerging trend for human computer interaction with the technology advancement in artificial intelligence and information retrieval. It can just listen to your voice, interpret and understand and act according to it. Now let's get into the project. I would like to discuss the hardware, protocols, and web services that is involved with this project. As discussed before, IoT devices are those that have Wi-Fi connection or access to internet. This project makes use of various embedded platforms like Raspberry Pi, Intel Edison, ESP8266, and ESP32. Raspberry Pi is a low-cost credit card size computer that plugs into a computer monitor or TV and uses a standard keyboard and mouse. It is a capable little device that enables people of all ages to explore computing and to learn how to program in languages like Scratch and Python. Intel Edison is a computer on module offered by Intel as a development system for wearable devices and IoT. ESP8266 is a low-cost Wi-Fi chip with full TCP/IP stack and MCU capability produced by a Shanghai-based Chinese manufacturer called Espressif System. ESP32 is a series of low-cost, low-power system on a chip microcontroller with integrated Wi-Fi and dual-mode Bluetooth. ESP32 series employs a Tensilica Extensa LX6 microprocessor in both dual-core and single-core variation. It is a successor of the ESP8266 microcontroller. MQTT is the protocol which is used in the project. It is an ISO standard publish subscribe based lightweight messaging protocol for use on the top of a TCP/IP protocol. It is designed for constrained devices and low bandwidth, high latency or unreliable network. This project makes use of MQTT-FX for debugging MQTT messages. MQTT-FX is a client written in a Java based on Eclipse PAHO. The client that publishes is called a publisher and all those receives is called a subscriber. Topic is a string word and is hierarchically aligned. The counterpart to a MQTT client is the MQTT broker, which is the heart of any public subscribe protocol. Depending on the concrete implementation, a broker can handle up to thousands of concurrently connected MQTT clients. The sensors used in the project are below. DHT11, which is a temperature humid sensor, the door sensor, which is a one switch read with a magnet creating a closed circuit, ultrasonic sensor, which detects the distance between two objects, PIR, which is a passive infrared sensor sensing in 120 degrees, photolight sensor, which the resistance decrease with exposure to the light. The actuators that is used in the project are relay board, servo motor, buzzer, and LED. The easiest way to simulate an output is through LED. Alexa is an intelligent personal assistant developed by Amazon, made popular by Amazon Echo and the Amazon Echo devices developed by Amazon Lab 126. It is capable of voice interaction, music playback, making to-do list, letting alarms, streaming podcast, and a lot other features. Alexa can also control several smart devices using itself as a home automation system. This project aims to control and automate devices using voice. The major advantage of the system is the ease of management for the user by not having his or her phone open and click on certain options to control things or go near the switch to turn it on. Now let's talk about Node-RED. It is a programming tool to wire together hardware devices, API, and online services in new and interesting way. It provides a browser-based editor that makes it easy to wire together flows using wide range of nodes in the palette that can be deployed to its runtime in a single click. Making an Alexa skill involves the following instructions. Let's discuss them one by one. The first is the developer console. We need to feed in the skill information. For now, I use the invocation name and the Alexa skill name as demo. This page indicates the interaction model. We have two different phases, the indent schema and the sample utterances. The indent schema includes the type of indent we try to invoke. We can either use a launch indent or an action indent. The sample utterances are I'm leaving the home, I want to leave the home, or you can even try giving commands like ask for some Alexa commands and it replies what all commands it can help you with. In the configuration menu, we'll have to enter the endpoint. For this project, I'm using Bluemix platform as an endpoint. Therefore, I'm using an HTTP secured endpoint, which is echo test node-red.bluemix.net. On the test page of Amazon Echo, I'm going to try an utterance like I'm leaving the home. Let's see what Alexa will return to me.
If you are leaving the home, then I can help you turn off your devices and lights. Do you want me to open the garage door?
So that's how Alexa replies to me if I say I'm leaving the home. Let's see what happens in the Bluemix end. This is the dashboard for IBM Bluemix. As you see, the dashboard shows two different names. The echo test is the one we are looking for and the state of it is running. Once you click on the link, it opens the Node-RED that flows in the cloud. Now let's do some real demo. I'm using EchoSim, which is a virtual Alexa, to test my code. Alexa, what's the weather in San Francisco?
Right now in San Francisco, California, it's 64 degrees with partly sunny skies. Tonight's forecast has mostly clear skies, with a low of 56 degrees.
Alexa, ask Demo, is anyone outside the door?
I can't find anyone outside the door.
Now let's discuss the Node-RED flows in different embedded platforms used in the project. This is the flow in Intel Edison. As you see, the nodes are self-explanatory. This is a mechanism to adjust brightness in an Intel Edison GPIO pin. I've connected the PWM D9 to my living room light. So when Alexa is asked to increase the brightness, it tests with the saturation level, and using a PWM pin, the brightness of the light is adjusted. This is the master control and is present inside a Raspberry Pi. It has the control over every IoT devices used in the project. It can decide to send email or SMS or do any sort of notification or take action on devices. This flow is embedded in the IBM Bluemix online service, so this can be controlled and monitored from any part of the world. All the important information is being recorded using a Cloud node. This is attached to a Bluemix platform. The dashboard for the Cloud NoSQL DB is shown. All the data is stored in the JSON format, and the important information is inside the payload. So the latest information from the door status is being shown as door open. So currently the door is open. I have the project setup being displayed. These are the 5 different IoT devices I use in this project. The first one is the Intel Edison, which is connected to a photo light sensor and a relay board. It also has an LED that is used to simulate the brightness control with the help of Alexa. The second is the ESP32, which has the motion sensor and temperature sensor. This device can be installed in the living room so that it controls the temperature of the living room. The third is a ESP8266, which is placed at the door. So the door sensor is connected to the ESP and indicates the current status of the door. The next is the Raspberry Pi, which is the master control. And we have an ESP8266 that has control over most of the electronics devices like garage door, kitchen lights, and so on. As a conclusion, voice can be used as the next generation user interface. Node-RED makes it easy for us to change decisions and make changes in the flow. The system is inexpensive and has no limitations of distance. Thank you.